Hello, everyone. Welcome to Surveying Group Podcast new episode. And we are going to talk about 3D scanning, photogrammetry, and NeRF. Joining me today, Jack Wang. He is CTO and co-founder of Curie Engine, one of popular mobile 3D scanning apps. So, welcome, Jack. How are you?
Thank you so much. I'm great. How are you?
Yeah, I'm very well, thank you. Before diving the details, let's start with mobile apps. How does a 3D scanning app works? What was happening on my phone? Can you explain the main process of the 3D scanning for anyone who doesn't know anything about it?
Yeah, sure, of course. So when you're talking about 3D scanning on your phone, basically there's about several approaches, different approaches to do the 3D scan on your phone, right? And before we jump to our own technology, there's LiDAR approach, which uses an iPhone Pro LiDAR on
Mm-hmm.
your back of an iPhone and to the LiDAR scan. And by basically using LiDAR, what you're really doing is that what LiDAR is really doing is like it's pretty much emits a lot of different, little laser dots and to the surfaces and it
Mm-hmm.
bounces back. And because we know the speed of light is, 3 times 8 to the power of 8 or something, meters per second. So just by multiplying that time to the speed of light, and basically you will get the distance measured of each laser emitters. So that's the idea behind LiDAR. But
Mm-hmm.
obviously, not everybody have this high-end, iPhone that equipped with LiDAR. So without the LiDAR, there's another approaches, which is also iPhone only. It's a Face ID approaches. With the iPhone, you have the Face ID to unlock your phone. And essentially, that Face ID, little hardware, it is a DOE sensor. It's a structured light sensor. Pretty much, it kind of emits a kind of infrared
Mm-hmm.
dots right to your faces. And because if imagine if you're pretty much emitting the light to a plain wall, it will have a very formatted kind of light pattern. But if you emit something not that plain, for example your face, the formatted pattern will start to deform, and then by measuring how much it deformed from its original form, then you can start to measure out the distances, and that's how the Face ID works. So yeah, so if you search on 3D scanner on your app store, you will find a bunch of different apps that uses a Face ID to do 3D scan. But yeah, and obviously not everybody has an iPhone as well,
Yeah.
and apparently like half of them are Android phones, and that's why our approach kind of stands out. What we are doing is we have a what we call the photogrammetry approaches, to do the 3D scan. And what it really requires is just taking a whole bunch of photos around an object. It doesn't require any, hardware associated with the phone. So you just need to take any phone you have and take photos around an object. And the technology behind the curtain is that we developed this algorithm on the cloud that can figure out the feature points on the object you were taking photos around. And then we use the algorithm to match the feature points on the object and start
Mm-hmm.
to create this dense, point cloud. And with the point cloud, can do the mesh, do the texture, and as a result, you get a 3D model. So that's what the magic happens
Yeah,
there.
as known as photogrammetry. Yeah.
Yes, yes,
Okay.
exactly.
And yes, by the way, do you think that mobile apps change the game in the 3D scanning sector?
Good question. I think the answer is yes and no. Excuse me. So basically, by saying yes, it's actually does lower the barrier of people, trying to do 3D scan, because before this, kind of 3D scanning app boosting up, the only ways you can do 3D scanning is either buy a really expensive 3D scanner, which usually costs about, tens of thousands of dollars,
Yeah.
or you buy the photogrammetry software, which also costs, $1,000. But also, not only you have to buy the software, you have to own a super powerful PC to run the software, which also costs a lot of money. Yeah, so I believe before the photogrammetry apps that's available, like the people gaining access to scan is real limited and high budget.
Mm-hmm.
But having said that, like by us introducing this 3D scanning app, to the smartphone industry, a lot of people who needed the 3D model but couldn't have the access to it, they can start to, gain
Yeah.
access to affordable 3D scan.
Yeah.
But in the meanwhile, like it doesn't really, shake the fundamental of the professional 3D scanning, because if you think of how, the aerial, kind of 3D modeling works, like you not only require a 3D modeling kind of service, you also need a lot of add-on features on top of the 3D modeling,
Yeah.
to be able to fulfill your specific requirements. So
Sure.
that specific kind of requirements are not something the smartphone app can easily do. And also from a startup point of view, it's not very efficient for us to do it, because you need to deploy a lot of manpower and resources to develop the specific feature that you need. But on the other hand, like people don't expect us to charge too much on a smartphone app basis. So yeah, so it's like, so from my opinion, it's gonna lower the barrier for people to enter, but yeah, it won't really shake the professional 3D scanning realm.
Yeah, of course, I totally agree with you because these apps allows to everyone to jump 3D scanning world in minutes and
Yeah,
create their own 3D models. That sounds very interesting, but of course, we have to define the requirements and what you want to know after the project, and
definitely.
you should define it first.
Yes.
But of course, there are some limitation on like every methodology. So, what is the biggest challenge in front of the 3D models, creating 3D models? For
Right.
example,
Yeah, go ahead.
one of the problems that I know is shining and smoothie surfaces like a mirror,
That's right.
as I mentioned, as you mentioned in your video,
Hmm.
and it is really interesting and informative. So, by the way, yeah, what do you think about that? What is the biggest
Right.
challenge?
Right. So definitely from the technology point of view, like you just said, like, this kind of technology, like doesn't matter how expensive they are. For example, you can spend like $3,000 to get a really professional photogrammetry software,
Hmm.
but the bottleneck's the same. Like you can 3D scan, mirrors, transparent part, or just about any object that does not have enough feature points.
Yeah,
For example, like a pure color monocolor
yeah,
object is not something can be scannable without preparing. Yeah, so that's definitely one of the biggest bottleneck in this whole technology.
hmm,
But from a startup point of view, again, like from me, putting aside of this technology, a challenge. Another challenge for us is that how to let people know about this kind of technological limitations.
hmm,
For example, because this is in form of a smartphone app, right? So people can just search on the app store and
yeah,
they think, oh, this is pretty cool. I can do something really fun with it. They just download without knowing anything or any background about the photogrammetry or 3D scanning. So they're like, okay, let's try scanning something easy first and see what this guy can do. And what they thought is easy is something like a water bottle. They thought that's easy, right? That's asymmetrical and that's even shape and with less detail. They thought, okay, let's give it a try. But guess what? Like in the end, like that's the most hardest object to be scanned with.
yeah,
So yeah, so for us, the another very challenging part for us is to try to educate new people who's trying to jump into this kind of game, but they didn't know what they're doing.
yeah,
We really need to let them know that, hey, here's the limitation. You need to know what you're doing before you can get the really good results.
yeah.
So yeah, so I believe technological, challenge and and educational challenge are the two main challenges for us.
By the way, many of earlier adapters are talking and using about NeRF, neural radiance
Hmm.
fields. Let's start again.
Right.
The definition is NeRF. What is it? Is it similar to photogrammetry? And how NeRF can understand the texture?
Sounds good. Very, very good question. So from a user point of view, to use NeRF doesn't really differ too much from user photogrammetry. Why? Because the form of inputs, are all the same. Because in the NeRF, what you're doing is you're pretty much taking a video or taking a whole bunch of photos around an object, which is exactly the same as you would do as a photogrammetry. You take a video or you take a whole bunch of photos around an object. And then in the end, you like both for both NeRF and photogrammetry, you also get a 3D kind of representation of the object, right? And we'll talk about the formats later. But yeah, but from the general user point of view, like they look really similar. Sometimes they even didn't know, because NeRF is really it's getting a really good big hype like recently. So where the new users, they know about NeRF, but they haven't heard of photogrammetry, which is like traditional way to do 3D scanning, and they saw us like just doing photos to 3D model. They're like, oh cool, that's a NeRF company. But yeah, although we are a NeRF company, but before we didn't use NeRF, we were like photogrammetry, but didn't know what photogrammetry is.
Yeah.
So yeah, so from a user point of view, they look really the same. We're similar. But from a technological point of view, they're really different down to the core, because what NeRF is doing is that it uses machine learning to try to learn what the lights, or what the neural radiance field, or what the light can be like with any given camera positions. Does it make sense?
Yeah.
I'm trying to be a little more simple here.
Yeah.
Yeah, but that's pretty much that what NeRF is trying to do. Is NeRF is trying to compute a mathematical model
Hmm.
from the given photos or videos, and to try to build a mathematical model that can represent the object from any camera positions.
Hmm.
So in this way, after we got a NeRF model, you just you can like Arjuna, what you're doing, you can just play around with your camera, rotate the 3D model. But instead of actually rotating the 3D model, what you're actually doing behind the curtain is that you are giving the NeRF model different camera positions. So NeRF is trying to render, or trying to learn, or tell you what the object could look like from any given camera positions. So yeah, so that's what NeRF. But photogrammetry, like I said before, it's using computer vision to figure out the feature points, compute the dense point cloud, and give you the mesh and texture on that. So yeah, so all the actual algorithm are completely different. And so there's another difference between NeRF and the photogrammetry is the output. Like I said before, they all output kind of 3D representation of the object, but the formats are super different, because the traditional like NeRF, like the original NeRF, it doesn't have the ability to generate what we usually use, the mesh, right? Because mesh is a general 3D model formats that can be used in a lot of different industries. But with the NeRF, it has this kind of mathematical model, but it doesn't generate mesh. It gives you what the model can look like from any angle, but it's not necessarily a mesh. So that's different. But nowadays, because a lot of people are working on the NeRF, they're trying to improve NeRF every single day. And now we actually see the ability for NeRF to generate mesh, although not as good as photogrammetry, but we see the result can generate mesh.
Hmm. Thank you for
Yeah.
explaining, and you also answered my next questions together.
Go ahead, don't
Yeah,
worry, I
yeah.
can
Okay.
go in more
Yeah,
detail.
that's fine. And another question is about, as you know, our community are mostly using photogrammetry for different geospatial solutions, and they are very excited to hear about NeRF. And do you think that NeRF will move to photogrammetry to the next level? And if yes,
Yeah.
how? Basically, again, what is the main benefit if we think, if you are working on geospatial industry, what do you think about, what is the main benefit? What do you think about that?
Hmm. Right. Very good question again. So basically, from my opinion, I'm a true believer that NeRF can replace photogrammetry eventually. Probably not right away, but it's definitely where the whole photo scanning is heading to. Because like you mentioned before, like the traditional photogrammetry has a lot of limitations, but NeRF kind of, it can be, used in a vaster kind of applications. For example, you can start to scan. I've seen people even scanning the water paddle, like, which is like completely non-scannable,
Yeah.
using the photogrammetry. But NeRF, you can actually start to do it.
Mm-hmm.
So from my opinion, I really think NeRF can replace photogrammetry in the future. But to fully achieve that goal, there's a couple of things we need to improve. From the company point of view, number one is the cost. Absolutely, because right now photogrammetry, I think like Kiri, we are actually the first to kind of super, like pretty much smash down the photogrammetry cost down to the like dirt. Pretty much we moved everything to the cloud, and we use a lot of engineering kind of approaches. We use CUDA, we work with NVIDIA, AWS, and to really trying to optimize the whole computational resource required for photogrammetry. So in the end, like we can achieve this kind of, we can even make the whole photogrammetry free for most of people and only charge for the professional features. So that's something we are really good at. But if you're trying to think of the same way using NeRF, then you will start to see some technological challenges, because a NeRF, it requires generally a larger computational resources than photogrammetry. So if you're trying to do the same business model, using the existing app, then we'll start to see it doesn't really make sense financially, because to train NeRF, if you want to achieve the same speed of generating 3D models, you will have to cost about 10 times more for us than actually doing the photogrammetry. So one challenge for us is to try to make NeRF affordable to everybody, so we can deploy NeRF on scale.
Sure.
Well, I know some companies are doing that, but they're doing that by losing money. I don't think that's a healthy business model, anyways. So as a company standpoint, we definitely need to tackle on that first. So that's number one. And number two thing is, if you compare like the perfect NeRF mesh versus a perfect photogrammetry mesh,
Yeah.
you'll realize that the level of details on NeRF is far less than the level of details on photogrammetry. So which is another kind of downside on NeRF. But from the speed of everything's going these days, the AI, the NeRF, the new papers published every day, I really do think like the level of details is a big thing to consider, because right now we are actually developing our own kind of a news algorithm, or NRS algorithm, that can generate a little more details than the traditional NeRF. So that actually can be tackled very soon. But if we solve both the level of detail question and the level, and the cost problem, and then I truly believe that NeRF can be the next, leap for photogrammetry and photo scanning.
Yeah. Thanks for clearance. And what do you think about the near future? What are some potential future applications of 3D scanning and NeRF? And of course, want to hear that what you are working on it as Curie team, and what we will see the next days from you.
So first of all, what we can do with NeRF, a lot. So basically, think about what we're trying to imagine on a 3D world. For example, people are talking metaverse like crazy, like last year, right? But this year they're getting a little bit cooled down, but still, like the future of 3D is still there. But it just got overwhelmed by AI and a lot of different things, but it's still there. But anyways, if you think about metaverse, then people were saying, hey, we can do shopping in metaverse, we can do gaming, and we can do meeting, we can do virtual working, we can do a lot of things, right? But if you try to imagine all these applications pretty much down to the core, like the core of any metaverse application is that you're interacting with different 3D models or 3D assets, right? And if you think of these, then pretty much you need all kinds of 3D assets to build up this different kind of contents and applications. And definitely NeRF is one of the most efficient way to try to build what we call the photoreal 3D assets and give you immersive experience with it. For example, you can do virtual shopping with it. You because actually I've seen people doing kind of AR shopping using photogrammetry technology already. But the only thing is like with the photogrammetry, like you're only limited to do AR, shoes try on or AR cap try on or AR bag try on,
Yeah,
like those kind of things that can be feature pointed,
yeah, it's
right? But good luck with it if you want to do like I don't know, for example, if you want to do like Coca-Cola bottle, right? Good luck with it because that's all transparent glass made, and we're yeah. So like if you're talking about AR, kind of shopping, then there's a lot of merchandises that cannot be digitized with the current photogrammetry, but NeRF can start to do
yeah.
it. So NeRF can open a whole bunch of doors for digitization, that cannot be achieved before. So yeah, so that's I think NeRF can be used in many ways. Yeah, and then back to our company, what we are working on right now, and obviously we try to lead the future of NeRF because what we are good at is we have a relatively large community who's are 3D artists, 3D creators, who are proactively into this metaverse building and this new kind of 3D interaction,
Hmm.
kind of discovery kind of game. So yeah, so they are the early adopters of the 3D pretty much creation. So we just try to give them a more advanced technology or more advanced tools for them, in order to build the virtual world better. So for us, like right now, we're working on NeRF, and people should be expecting to see Kiri with the NeRF in next 2 to 3 months.
Oh, so
And but
close.
with our NeRF, like I said before, yeah, very close. Like we are deploying that to the cloud. If everything works out, we should have a testable version this week. But yeah, but what's exciting about our NeRF is that I think, well, at least I believe, we solved the problem that NeRF, the problem that NeRF cannot generate mesh and the NeRF cannot provide high detail 3D mesh. So I believe we solve these two questions in the efficient way, so that when people using our NeRF, they'll realize number one, okay, you can actually get a really decent mesh in 5 minutes, and second, they start to can't tell. Okay, is that photogrammetry or is that NeRF? Because I can't tell until they try, water bottle or something that cannot be 3D scannable with the photogrammetry. So I think we're reaching out a point that people, it doesn't matter as a photogrammetry or NeRF. What people are always getting is a perfect 3D model for them to use. So yeah, so that's definitely what we're super excited
Yeah,
about this
yeah,
week.
exciting to hear that. And it was really a tasty conversation, and I think we have recorded another one again. Well,
I'd
thank
love
you
to.
so much and joining us today and sharing your insights. By the way, to stay informed, Kiri Engine and Jack, his YouTube channel is the best way, I think. Reach out to him. Jack is building Kiri, right? Thank you, Jack. See you again. Bye.